Welcome back, students. This video we're going to cover Module 9, Topic 3. This is part two, excuse me, part 2 of Topic 3, which is still part 1 of Trigonometry. So that's why we're going to call it Module 9, Topic 3, Trigonometry, Part 1.2. So it's a little less confusing, I guess. So we're on page 8 of the Module 9 packet. Go ahead and get right into it. The objective of this lesson, you guys are going to solve problems using trigonometric ratios. Yes, in the previous lesson, part 1.1, we'll call it, we talked about trigonometric ratios. We talked about sine, cosine, and tangent. And we used those to find the missing side. We're going to start out doing that again. Practice here on the bell work and then the extra practice here. Guided notes at the bottom is going to explain how we're going to find the missing angle when we have both sides. So yesterday, our previous lesson was we have an angle in one side to find the other side. And today, or in this video, a little later, we're going to learn how to find the acute angle in the right triangle based on two side lengths, whether that be the opposite, the adjacent, or the hypotenuse. And I'm going to show you guys how to determine what two sides we're using so that you can, once you get that part down, and I said this in class today, once you get that part down, the trig's easy. I mean, the calculator is doing it, and dang it, I still didn't bring, I gotta remember to bring one of the calculators home from class, because I've got to do a video on that for you guys. Plus, I want to be consistent with how we're working on these things. I'm looking for my other calculator. I guess it'll be the phone for this evening again. Excuse me. Let me put it on Do Not Disturb so I'm not fighting text messages again. Sorry for so much dead air, guys. I know you're ready to get the notes going, not listen to me chatter. Okay. All right. So, again, page 8. Just square up here. So, bell work. We're going to look here. Number 1. Find the trig ratios for the following triangle. All right. So, number 1, they want the sine for k. So, k, the sine is sine is opposite over hypotenuse. Tangent is opposite over adjacent. And for good measure, cosine is adjacent over hypotenuse. Excuse me, sorry. All right, so for our sine for k, so k is on the top, our opposite is the bottom. And the hypotenuse is always where the box from the 90-degree angle points. So opposite over hypotenuse, or 12 over 13 for the sine for k. Now, tangent for j, I'm going to do this in different colors. So the tangent is the opposite over adjacent. Well, don't use this because these are for angle k. For angle j, it's on the right, so its opposite is the left. See, k's opposite was here, j's opposite was here, and the adjacent would be flipped as well. We'll talk about that later in the lesson too. So tangent for j, opposite. So the opposite here is 5 over the adjacent, which is 12. All right, number 2, solve for side CB. So they call it X. So this is more like yesterday. This was just more practice setting up our ratios. So number 2, so we have angle A, here's a 62-degree angle. If it's on the top, down here, X's are opposite, and then we have a measure for our hypotenuse. We don't have a measure for the adjacent, so we wouldn't have been able to use cosine, because cosine uses adjacent over hypotenuse. So we're going to say opposite over hypotenuse is sine. So the sine of this 60-degree angle is equal to x, which is the opposite, over 10, which is the hypotenuse. All right, solve for x. We're going to get rid of the fraction by multiplying both sides by 10. Going to cancel. X is going to equal 10 times the sine of a 60-degree angle. So I write x equals, I'm going to get my phone to use my calculator, but we're going to use our calculators at school. You will see the buttons are the same. This has a second button here. The one at school is green. Here it's just a second. We're going to use that later in the lesson. But for this, so 10 times. So we put the angle measure in first before we hit sine. So we're going to hit 62 sine. Now on the calculator at school, it's going to give you that ratio. On the phone, it's different. So this is why I want to show you guys the way we do it at school, but we're going to do it this way for the moment. All right, so 10 times sine 62 equals 8.82. We're going to just keep it at 8.8. We're going to, unless it tells us, we're going to round to the nearest tenth. All right, so we've got some extra practice here. More of yesterday, I ended up assigning in class the extra practice at the end of this lesson, thinking it was all finding the angles, but half of it is like this, so that's why I'm okay with going over these examples. It'll help with page 11. Page 10 is going to be finding the angle. Page 11 is going to be more practice like this. Okay, so number one, we're finding the missing side. We got x over here. Here's an x. Here's an x. Just going to fill them out. All right, so my angle M has my measurement. So I remember I need one side in the angle to give me enough information to get that other angle. So x is across from that 90-degree angle, so that's the hypotenuse. The 71 is on the angle that touches my angle M, and it's not the hypotenuse, so that has to be my adjacent. Also, angle M is on the left, so the right side would be your opposite. So we have an adjacent, and we're looking for the hypotenuse. That's going to be, I can't see it now because I moved the paper, but cosine. So cosine, and our angle is 72, and it's going to equal our adjacent, which is 71, over our hypotenuse, which is x. That's the side we're looking for. All right, so we multiply both sides by x. We're trying to get x by itself, so that gets rid of our fraction. So we'll take it down. X times cosine 72 is going to equal 71. And we're still trying to get x by itself. So we got to divide both sides by cosine 72. So now x equals 71 divided by cosine 72. I'm going to go ahead and write x equals because I'm going to get the calculator or phone. So 71 divided by 72 cosine, so this looks like that, equals, so 229.76, we're going to round that, make it 229.8. Now I'll stop right here to ask, as we're solving problems, and I've mentioned this before, when you get your answer, you should always ask, does my answer make sense? Well, if my shortest side is 71, see how much longer that hypotenuse is? 229 is a lot longer than 71, so that does make sense. All right, so number two, angle, what is that, H, is 42, so that's the angle we're looking at. It's on top, so down here, X is on the opposite, the bottom, or the opposite of my angle. 4.6 is across from my 90-degree angle, so it's my hypotenuse. So sine 42 is going to equal my opposite, which is x, over my hypotenuse, which is 4.6. I'm going to multiply both sides by, not by x, but by 4.6. Gets rid of that. Then x, I'm just moving this over here, writing it backwards, x equals 4.6 times sine 42. 4.6 times 42 sine. We got 3.07. We're going to round that to 3.1. I forgot to write x equals. So this is our shortest side. Our hypotenuse is 4.6. 3.1 makes sense. All right, I'm going to go blue over here since we got over the line. Number 3. So this angle J is 51 degrees. So we have nothing over here for the hypotenuse, so we can't use sine or cosine, so we have to use tangent. Remember, tangent is OA, or opposite over adjacent. So if my angle J is here, this is my opposite, so that's 66, and then my adjacent, this is the side touching my angle that's not the hypotenuse, is X. Oops, forgot to write. 51. Okay, multiply both sides by X. You got to get rid of the fraction. These cancel. X times tan 51 equals 66. Now we got to divide both sides by tan 51 because we want X alone, right? So now X equals 66 divided by tangent 51. Okay, so now 66 divided by 51 tan equals 53.44. We don't round that. We're just going to say 53.4. Easy peasy, right? Sorry. Okay. Forgot a little sideways. All right, let's scooch down here to the bottom. All right, so the reminder from the previous lesson, we use trigonometric ratios to find missing sides from triangles. Fill in the blanks. So opposite over hypotenuse. Remember, it's SOHCAHTOA. SOHCAHTOA. So sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. And these are on the reference sheet. We've started using those in class, and that definitely, I like to see you guys with those in your hands. So all this stuff is on the reference sheet. So is the information we had in lesson 1 and 2 about the special right triangles. So to find missing angles, we're going to use the inverse functions. So sine with this -1 exponent is basically inverse sine, inverse cosine, inverse tan. You're like, well, where's that at? Well, when you hit, so notice the second button is gray. Sine turned into sine to the -1st power, or inverse sine, inverse cosine, inverse tan. I like how this shows because the calculator, it has it written in green above it. But see, if we don't touch it, it's just sine, cosine, and tangent. But if we go second, it's the inverse. Just like these under the bottom, which we don't worry about, but R3. So, that good info for the next page here. We're going to flip over to page 9. Where did 9 go? There it goes. Sorry about that. Okay. All right, page 9. Just going to re-scooch here so I can fit on my table. Okay, so just like the previous lesson, we have another triangle set up here. This is going to show us how to do what we're doing today, what we're learning. This is the slow learn. So we're using the inverse of sine, inverse of cosine, inverse of tangent. So solve for missing angle. See, neither one of these angles has a measure, but we have two sides. So we're going to find what is a measure of angle A. And so we're going to find it for A. Highlight the angle theta. So we're highlighting angle A as theta. Theta, that means the angle that we're talking about. So for this problem, what we write here is going to have to deal with A, or angle theta. So 24 down here, this is the side that's touching our angle, but it's not the hypotenuse. The hypotenuse is over here, across from the 90 degree. So this is our adjacent. And here, let me just make sure. My pages are all crazy over here. Hold on. There it is. There it is. Okay. And then A is on the right, so the opposite is over here on the left. So opposite over hypotenuse, that's your cosine. So label the sides. I got ahead of myself. So label the sides, hypotenuse, opposite, and adjacent. Determine the trig ratio. So which one of these can we use? Adjacent over hypotenuse. So that's cosine, or the inverse cosine. So inverse cosine equals adjacent, which is 24, divided by the hypotenuse, which is 26. So now we're going to use the function on the calculator. It's going to be super easy. Just a moment. Okay. So we go 24 divided by 26. So this is going to give us the ratio. So you see it's 0.93. All right, so now we want the inverse cosine. So second, or just say inverse when you hit that button, cosine. And see here I have to enter on the calculator at school. I don't. So when we do the inverse cosine of 24 divided by 26, which is that 0.9307, blah, blah, blah. This tells us that this angle is 22.6 degrees. So the measure of angle A is 22.6 degrees. Or you could have wrote the measure of angle theta. Either way, both are correct. Okay, scooching down the page. Never mind the numbering when you see these weird numbers. Number 3. What is the measure of angle F? So F is down here. They've already marked it x degrees. So we have two sides. We don't have a hypotenuse. So we only can use tangent because we have an opposite, which is over here, and the adjacent, again, the side touching the angle that's not the hypotenuse. So we're going to use opposite over adjacent. We're going to use the inverse tangent. And it's going to be opposite, which is 4.9 divided by adjacent, which is 2.9. Okay, so 4.9 divided by 2.9. That's our ratio. And then the second still hit because I haven't changed it, I guess. So we're going to hit tangent. And then we have to hit enter on this. It's different on the calculator at school. My apologies. I promise I'll go back and we'll fix it, or we'll do it again with the other calculator. Actually, I'm just going to do a video with the calculator. So now this, our angle F, it equals 59.4 degrees. We round it up. 59.4 degrees. Sorry, it's a little messy. All right. All right, so here they want B. So B's on top. 24 down here is our opposite. So these numbers look similar. And then 26 is our hypotenuse. So we have an opposite and hypotenuse, so we can use inverse sine. And the opposite is 24, and the hypotenuse is 26. So 24 divided by 26, same 0.93, just like it was up there. And this time, though, we're using the inverse of sine. Hitting enter, we have a 67.4 degree angle B, 67.4 degrees. Okay. Let's scooch down to the bottom. All right, number 3. Again, don't mess with me with this silly numbering. All right, so Terry was painting on a 10-foot long ladder resting against a wall. The top of the ladder was 8 feet above the ground. What is the measurement of the angle the ladder makes with the ground? So if you guys watched the previous video, we had the ladder and we were trying to figure out how tall the ladder was. They told us the angle that it made. So here we know the ladder and the side, we need the angle. So the wall makes a 90-degree angle with the ground, just like you do when you stand on the ground. Said it was 8 feet above ground. Ladder is 10 feet tall. They want to know what's that. Okay, so this angle over here's the opposite, over here's the hypotenuse. Opposite, hypotenuse. Sine, the inverse of sine is what we're going to use. So the inverse sine, 8 over 10, or 8 divided by 10. So we still got the second button pressed. So 8 divided by 10 is 0.8. And inverse sine, so it says a sine, which is the inverse, equals. So the angle made right here is 53.1 degrees. So x squared equals 53 point, I'm sorry, x degrees. Excuse me. Ugh. 53.1. All right, let's flip over. We have one more practice problem at the top. And then I assigned this, we did different things today in different classes. The first period, I think we got through this page. Second period, we got through this. And then that's when I noticed the second page had sides on it. So we did the first one together, and then I assigned the rest. And then fourth, yeah, you guys, I think, got through the bottom of page 10. So I'll do the first one here because, actually, no, I'm not going to do any of them. We'll just, these work the same as this. Follow me here, except here I'm going to find cosine and sine. I'm going to show you something up here. This is just what we did on the other side. I'll show you when we get to the bottom. So anyway, number 4, top of page 10. Consider the following diagram. So we have another right triangle. Big surprise. So our box points this way. So here's our hypotenuse. I'm going to label these before. Actually, the hypotenuse is the same for both angles. So they want the cosine of C, sine A, measure of A, measure of C. So we'll do the cosine and sine first because that's what I want to show you. And then we will, I'll give you the measures. And then that'll set you up for how to do the practice down here, which is homework. Okay, so up here. So we'll start with C. I'm going to make it blue. Hypotenuse will be the same, you'll see. But so for C, the side that's touching the angle that's not the hypotenuse is 36 over here. That's the adjacent. And then it's on the bottom, so 77 up here is the opposite. All right, so I'm going to label angle A in red. So hypotenuse, still across from the angle, so it's the same. But notice this side is touching A, that's not the hypotenuse. So this side is its adjacent, and because A is on the right, this side's on the left, so it's opposite. So what do we notice? We notice that this side is the opposite for A, but it's the adjacent for C, and this side is the opposite for C, but the adjacent for A. I bet that the cosine for C and the sine for A are going to be the same thing because these numbers are going to be just flip-flop. So let's try it. So cosine C is going to equal adjacent. So C adjacent 36 over hypotenuse 85. So now let's do the sine for A. I just wrote that in red. That's okay. All right, sine for A. So A's here. The sine is the opposite. So it's red, opposite. So 36 over hypotenuse. So both of them are 36 over 85. Same number. And that's what, so supplementary angles, and that's what these guys are. Remember, this is 180 degrees and this is 90. These two together have to equal 90. And the definition of two angles that equal 90 is supplementary. Supplementary angles, how do I word this? So let's see, now we're going to say they share sine, cosine, and then like this. Hopefully that you get what I'm trying to say. All right, so now let's go back here. So the measure of angle A, so we have 3 lengths. We can use any of them, but we're going to use, so the sine for A, which would be opposite, so we're going to use the inverse sign to find angle A. So it's going to be opposite, which is 36, over hypotenuse, which is 85. So this number. So hold on. 36 divided by 85 equals, so that's that number. I'm just going to write it over here, 0.4. We're going to say 0.424 because we're going to round right here. All right, so now we want to find the inverse sine for that, which is 25.05. And I know we would normally round, but I know what's going to happen. These angles are supplementary, so we're not going to round. We're just going to call it 25 degrees, okay? Trust me. So the measure of angle A is 25 degrees. All right, so measure of angle C. We can use any of these. Let's see. So if we use the sine for C, we'll just use sine just because we did it. We can use any of them, but we're going to use sine. So C, its opposite is up here, 77. And the hypotenuse is the same, it's 85. So we're going to have a different number, but they'll all work. So 77 divided by 85, so there is our ratio. And now we want to find the inverse sine. So notice it's 64.94. We're rounding that to 65. And measure of angle C is 65 degrees. Well, 25 plus 65 equals 90. So if we'd rounded here, it would have been over. That's why I said not round, even though I knew we were rounding there. You can't round up in both places because then you're over. So we had to do it that way. But see, these are supplementary angles. Notice the sine for these are the same. They're both 0.42. I'm sorry. The sine for A is the same as the cosine for C. Let's just say there. Forget all this. Let's go use that. Okay, that concludes this video. So for you guys that are absent, you're watching this. So once you're done, you have homework, page 10. We have 1, 2. Again, don't talk to me about the numbering in this thing. I don't know what happens. This is 3. This is 4. And then we flip over to page 11, but then we're at 7 and 8. But again, we're finding the side here. Side here, side here. 9 and 10 are both sides. 1, 2, and these guys at the bottom, we're looking for angles. So complete those for homework. Reach out, send me a message in Teams or in Focus if you have any questions, or just ask me tomorrow in class. Have a great night.